Hi students, welcome back. This is Plus One Computer Science and Computer Application Chapter 2 Part 8 video. Before getting into the video, please do subscribe. And in this class, you are going to learn binary representation for signed numbers. Okay, in today's class, Chapter 2, that is number system, you are going to learn binary representation for signed numbers. So numbers, we do have positive numbers and negative numbers. So what is positive numbers? They are unsigned numbers, and negative numbers are signed numbers. So positive numbers, for example, let us say a decimal number 57. So 57, if I write 57, it is understood that is this number is a positive number. We have no sign in front of this, but still it is positive number. But negative number we have to represent with minus sign. That's why it is called as signed numbers. Negative numbers are signed numbers. These numbers are decimal numbers. But binary numbers, we have other way to represent negative numbers. So the simplest method to represent negative binary numbers is called signed magnitude. And in binary number, we never use sign. There is no positive sign, negative sign. We use signed magnitude to represent negative numbers. So let's see the technique, how it works. So for example, let us consider a negative number, that is decimal number, minus 43. And 11010101 is the binary equivalent for this minus 43. So most significant bit is 1. That is the bit used to represent a number as negative number. So most significant bit is signed bit or parity bit. It is used to represent a negative number. So signed binary number has 8 bits. It should not be less than 8 bits. It is complete 8-bit number. In this 8 bits, 7 bits are used to store values. That is what? Magnitude. We say it as magnitude. 7 bits are magnitude. And the most significant bit is used for sign. It is called sign bit. So how it is represented? If the most significant bit, if it is 1, then the number is negative number. And if the most significant bit is 0, then it is positive number. So here I have written a binary number for negative decimal number. So now let's learn how to represent a binary number for given negative decimal number. So here we use 1's complement representation and 2's complement representation. So now let's consider an example minus 43 base 10. So this is the given decimal number. We have to do 1's complement and 2's complement. So 1's complement and 2's complement is applicable only for negative numbers. Do remember, it is only for negative numbers. So let's find 1's complement and 2's complement for the given negative number. So first of all, identify the binary equivalent of the given decimal number. So step 1, find the binary equivalent of the given decimal number 43. So simply convert the decimal number 43, positive 43 to binary equivalent. And later we have to find 1's complement and 2's complement, and the result will be negative 43, that is minus 43. So use repeated L division method to find binary equivalent of this 43. So we do have two methods to identify the binary equivalent of given decimal number. You can use repeated division method, or you can use sum of power of 2 method. It is completely your choice. So step 1, write the binary equivalent of 43. So 43 is equal to 101011 base 2. This is your first step. Step 2. Now it is time to count how many bits are there in the given binary number. If it is not of 8 bits, we have to make the binary number into 8 bits. Simply add zeros. So here we have 6 bits. Total 6 bits are there. So I added 2 zeros in front and write the complete binary number as it is. So the meaning or the value of the given binary number will not be changed. Step 3. Invert all the bits of the given binary number. So this step 3 is actually 1's complement, that is inverting all the bits given in the binary number. So how to invert? If you have 0, we have to write 1. So once again 0, so we have to write 1. If it is 1, we have to write 0. So this is what inversion. So 0 means you have to write 1, 1 means you have to write 0. So the given binary number we will invert into this format. So we have to write there 1. Now 1 is given, so write 0. And the next bit is 0, so you have to write 1. And continuous bits are 1, so we have to write 0. So this is the result of 1's complement. So binary number, first we have to make 8 bits and then we have to invert all the bits. And the final step is 2's complement. So with that it is getting over. 2's complement means we have to add 1 to the least significant bit. So this addition should be done for the 1's complement result. So let's do it. 1's complement, let's write the number, that is 1 1 0 1 0 1 0 0. And to find 2's complement, we have to add 1 to the least significant bit. So simply add 1 to the least significant bit. The result will be 2's complement. So 0 plus 1 is 1. And remaining all the numbers you have to write as it is. So this is the result of 2's complement. That is minus 43 base 10 is equal to all these numbers 1 1 0 1 0 1 0 1 base 2. So this is the binary equivalent of minus 43. Now look at the most significant bit. It is 1, that is sign bit. If it is 1, then the number is negative number. So let's try with another example. Let us take minus 15 base 10. We need to find the binary equivalent for minus 15. So let's do it. We do have 4 steps. Let us find the binary equivalent of this given decimal number. So binary equivalent of plus 15 is 1 1 1 1. So this is what binary equivalent of positive 15. Now what we have to do? Second step, we have to make it as 8 bits. So the next line is 8-bit format. Just add 4 zeros in front of this given number. So the meaning or the value will not be changed. And then write 4 ones. So this is the 8-bit format of 15. Positive 15. So 8-bit format is over. Next step is 1's complement. So what we have to do for 1's complement? Simply invert all the bits. So if you find 0, we have to write 1. If you find 1, we have to write 0. So 4 zeros are there, we have to write 4 ones. And 4 ones are there, we have to write 4 zeros. Yes, we have completed 1's complement. Now we have to add 1 bits to find 2's complement. So simply add 1 to the least significant bit. So 0 plus 1 is 1. And rest all the numbers will remain as it is. So this is the result of 2's complement. So minus 15 base 10 is equal to 41301. 41301 base 2. So this is the result. So it is used only for negative numbers. So here you have to note one thing, especially when you do addition, 0 plus 1 it is easy to do, but at the same time if the least significant bit is 1 and if you are going to add 1 to this particular number. So let's see how to do this. So 1 plus 1, obviously we say it as 2, but it is decimal number. 2 is decimal number. So in that case what we have to do? We have to find the binary equivalent of this 2. So binary equivalent of 2 is 1 0. So whenever you do addition for two binary numbers, we have to bring binary number only, not decimal equivalent. So 1 plus 1 is 1 0. In this case it is 1 0. So what we have to write here, the sum we have to write it as 0 and take 1 as carry. So this calculation will be explained in detail in binary addition topic. So we know that 1 plus 1 is 1 0. Again it is repeated. So you have to write 0 there and 1 as carry. So 0 plus 1 is 1. And the remaining numbers will be written as it is. So this is just a note in case if you get the binary number and least significant bit as 1, you have to follow this procedure. It is not 2, it is 1 0. So here whenever we get 2 digit after addition 2 digit, least value we write it as sum and the most value we write it as carry. The same thing done here. Least significant bit is sum bit and most significant bit is carry bit. So totally we do have 4 steps. First we have to find the binary, then 8 bit, then 1's complement, then add 1. So only thing you have to check whether you get 0 plus 1 or 1 plus 1. So in case if you get 1 plus 1, then you have to follow this step. Okay, now it is your turn. Try by yourself. Write the 1's complement number and 2's complement number for the following decimal numbers. So I have told you already that this 1's complement and 2's complement is done only for negative numbers. In case if you get positive number, then you have to say the reason that the given number is positive number. That's it. Never try 1's and 2's complement for positive number. And the remaining all the numbers you have to do it because all the other 3 numbers are negative numbers. Try these 4 steps for each negative number and highlight the 1's complement value and 2's complement value. So that's all for today. Thank you.